What's up? I'm so bad whenever these live streams start, I'm so bad at, knowing when it's actually going because I feel like there's like a 20-second lag time, and it just always, no matter what, throws me off. But I think we're good. I think we're good. Give me some, chat messages if we're good, if you can hear me and everything. Alright, I the lag always gets me. I like, yeah, it's weird. It's weird with these live streams. Awesome, glad everyone can hear me. Where's everyone watching from? I always like to I like to see. Brazil, nice. Loud and clear, cool. Yeah, I don't do many live streams, so it's probably many people many people's first time joining me for a live. I wanna do more though. I feel like they're pretty fun. I just need to get more, comfortable with them. Pandas, 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 pandas. Love it. People from all over the place. Cool. I'm gonna just get into things. Um, eh, Throughout the presentation or like, throughout this little session, we'll do some live coding and everything. I think the first thing that I would mention is that, the repo can be found here, and this is the same repo that we worked off of for the last live stream that I did, which was, kind of cleaning up this data set. But, here's the link to the data set. You can check it out now. It's also every link will be in the description, so feel free to just look at the description if you ever get lost on these links. Alright. Yeah, live will be saved too, so you can always watch it. I'll add even, like, a timeline and everything, so I plan on kinda going for, like, I don't know, maybe 2, max 3 hours. We'll see how things go. I feel like I always am overly optimistic with how much code I can squeeze into a live session. There's always more questions and everything. I see there's a question where I'm from. I'm currently in New Hampshire, the great state of New Hampshire. Motto: "Live free or die." Beautiful state, but, I live in, Boston area. I've been kind of in this area my whole life. Awesome. Alright, so what are we gonna do today? Well, we're gonna do some Olympics data analysis. Um, if people aren't aware, the Olympics kicked off yesterday. There was, the opening ceremony and everything. It looked pretty rainy, didn't look like the best weather, but cool to see the Olympics happening again. It's pretty exciting. I don't know, I feel like Paris has some cool features where, like, I know I used to be a skater boy. I know, like, the skateboarding course is, like, right down in one of the most popular parks. I know they're playing beach volleyball right by the Eiffel Tower, so a lot of cool stuff happening in the Paris Olympics. Figured it was a good time to just analyze the Olympics data set a bit more. So, a little bit of information. And can everyone see the slides on the screen too? I don't know if they're gonna load. Oh, they're loading, cool. So, I alright, a little bit about the data set, just for people that didn't maybe watch the, the last live stream. Basically, we have a data set. There's a site called olympedia.org, and it's kinda funny because I was checking out this site yesterday, and maybe if people go to olympedia.org, you're gonna have troubles right now. I think because of all the Olympics enthusiasm, their site got overloaded and, yeah, just basically wasn't even loading for me. But here's a screenshot of what the site looks like. You can definitely explore it. But, basically, the process for collecting this data set, it's worthwhile knowing, is that there's a site, olympedia.org. They do a great job of collecting all of the Olympics information and results from all the way back to, I think, 1896 they go to. So, historically, like, the modern Olympic Games do a great job of collecting all that information. That being said, and the site is cool too, but that being said, it's not, accessible to analyze, easily. So I wanted to be able to do more stuff with Python and Pandas and share that all with everyone here. So the kind of process was taking this website, going to each of the athletes' pages, and you can check out this website if it loads for you, but going to all the athletes' pages, scraping the HTML tables kind of on their results, and doing that for every single athlete, and then aggregating it into one data set. The kinda next step in the process was, that alone left a lot of room for improvement. It wasn't super easy to work with that data, just freshly scraped and that's it. So, the last live stream, which is still accessible on my channel, basically, we went through the process of some basic cleaning of that data and kinda how to, uh, use Python to help you make it a more accessible data set. So that's still there. I also linked it in the description. And then we also use the same exact data set in the most recent full pandas tutorial. So quick um, plug to that video if you haven't checked it out. Recently, I think a month ago now, released a new pandas full tutorial. So shameless plug of that, but we do some kind of high level analysis using pandas, kind of like I would say the core fundamentals that you need to know when doing any sort of data analysis with Python. And then so this video, kind of the premise here will be more advanced analysis. So as you can tell by this really, really good image, uh, there's some things that weren't covered in that high level pandas tutorial that I think are good to cover. So like working with external libraries and APIs, um, uh, building actual dashboards that you can toggle and deploy and share with anyone to make it, uh, share your code and share your analysis. So we'll build a dashboard with this, and then maybe do some like kind of time series type stuff. I'm seeing still some people from all over. And yeah, as you can tell, this image is super real. This was me fighting off, Python and data, doing advanced data analysis. Alright, so I think with that, we'll get into the code. Link is in the description. I do quickly wanna say and give a plug to an upcoming course that will be out this week. Um, I've been working with Posit, and if people aren't familiar with Posit, they build a ton of open source libraries, including Shiny, which is an awesome one for dashboards. And so I have a full course on Shiny for Python coming probably, I'm gonna say Thursday, it's gonna be released. Uh, yeah, super my favorite way to build dashboards these days with Python. And I do wanna say thank you to Posit and Posit Connect specifically for sponsoring this live stream. So, as you'll see in this video, Posit builds tools like Shiny, which will allow us to build this nice dashboard that will showcase all sorts of country information on, Olympic athletes from whatever country you wanna look up. But I think one of the biggest challenges with anything data science, anything, uh, you know actually getting your code to production, sharing it with team members, sharing it, deploying it at scale, etcetera. All of that is not easy, and so tools like Posit Connect make it much, much simpler to kind of automate and simplify your analytics workflows. You can deploy securely all of your apps, whether that be Shiny that we'll work with in this video, but also Streamlit, Plotly Dash, Fast API, any kind of Python app that you wanna deploy, Posit Connect can help you do that, easily, and it can do it securely, so, like, you can only share it with certain people on your team, etcetera. Um, I'll talk more about Posit Connect probably later on in the live stream, but you can, get started for free down in the description. But without further ado, let's get into the actual code. So I think as a good starting point, let's go to the repo that I shared in the description. Let me share my screen and make sure everyone can see. If people ever have trouble, actually, how do I do this? Still figuring out the software. I want to share the full screen. Oh, there we go. No, I want it to be full screen. We got this. I believe him. Replace screen sh no. No. Sorry, I'm technical difficulties here. Oh, here we go. We got it. No. I want full screen. Oh, man. Oh, I guess my screen is a different size than the actual live stream. We're good, we're good. Don't mind the, that will be fine. Yeah, I'm sharing my Mac screen, and I guess the dimensions of the Mac screen are a little bit different, but it's not a huge deal. But you can go to this link. My recommendation is probably to fork it, and if you don't yeah, if you don't know how to do all this stuff, not a huge deal. You can also access the data files, directly by just copying or downloading these files. You can, like, click in, view raw, or download raw file, so you can work with these CSV files locally without downloading all the code, but sometimes it's easier to just get the full repo, so recommend forking it. You can then, once you fork it, have your own copy of it, copy the URL to the dashboard, and you can open up a terminal window, and few steps here. I mean, I usually just go ahead and find a repo that I'm happy with. Hopefully, everyone can see this all right, but I have a code folder. I made a live stream folder. I'm gonna go ahead and just clone the repo here. So I've copied that link, cloning it here. And then kind of a good step I would recommend next, you don't need to follow all of this, exactly, like, these aren't super critical steps, but a good practice with anything code related is to create virtual environments when you're working on a new project. So, with at least on Macs, you can create a virtual environment by running the following command. Um, it's pretty similar um, with Windows, and then you can activate your virtual environment by doing don't worry if you can't follow this. This is like I'm going through it kinda quick. I just wanna showcase this as a good, um, practice. Activate your virtual environment by doing source ends Olympics bin activate, and then a good practice is go into that cloned repo. Usually in Python open source repos, you'll see this requirements.txt file. In it, if we look at it, you'll see a bunch of Python libraries, and typically, if you're working on an open source project, these will be all the libraries that you need to actually operate on that project. So you can do a pip3 install -r requirements.txt, and that will give you all the libraries that you need to work on that project. So that's kind of a good starting point. Then I would say open up a code editor of choice. And I do see another comment on the recording be available? Yeah, the recording will be available. I'll keep this up. Don't worry about if you have to jump off, miss anything. Recording will be available. Um, cool. So we have that. I'm gonna open up Visual Studio Code. It's kind of how I my editor of choice right now. Go into that repo and open this. Hopefully everyone can see all right. And I will create a new I typically, whenever I'm, like, starting on a new project, I like to just have, like, an analysis.ipython notebook, and I'll make this bigger so everyone can see. Okay, so we have this clean data folder, and if you didn't download these files specifically, you can download them raw, or the raw file, you can access them locally, but always a good starting point is to just check out what we're working off of. The data source, I see someone asked about the data source. There's some information about the data source in that repo. The repo, just one more time, is right here. All the links that you're probably wondering about will be found in the description, so you can find those if you can't, figure out, how to access the data. So all this data came from olympedia.org, and it was scraped, from there. So, I mean, a good starting point, we saw this in the last Olympics dataset and as well as the full Python Pandas tutorial, but I always just like to see what I have in my data files. So I'm gonna import pandas as PD. I'm gonna use that Olympics dataset. And if you're using, Visual Studio Code, you can do Command Shift P or Control Shift P, depending on what you're using. You can select interpreter and pick that specific virtual environment, or you can just use your default installation, Python. So I have pandas now, and now a good starting point is I'm gonna load in some of my data files. So my directory that I'm gonna be loading them from is this clean data directory, and I sometimes will just load in all of my data files with different names that are descriptive. I'll do like a BIOS equals pd.read CSV. I'll use an F string, and then I'll do my directory, and that is in bios.csv. We see this data file. And I'll copy this basically and just do it with the other files as well. I'm gonna load in all the files that I think we'll probably need right from the start. I see a working through Jupyter. I don't know if that's saying you're using a Jupyter Lab, Jupyter Notebook. I am using a Jupyter Notebook. I personally like this, but I will probably bounce around to some strict Python files as well, and then all this pops for the population info. You'll see what all these files are in a sec, but I'm just loading them all in at one go, just so I have them all accessible and I can do some analysis with them. Okay, so now we have all these files loaded in, and the first step I usually do is just some escape M to make it a markdown cell. I'll usually just start with like some exploratory data analysis. I just want to know what's in my data, and then we'll start answering questions that are actually interesting about this data set. And I'm going to make them challenging topics that I think that you won't maybe see in the overview Python Pandas tutorial. Make you work a little bit harder that are maybe more real world esque. Um, so, what do we have in this BIOS information? We have information about all of the Olympic athletes all the way back to, 1896 or whatever when these guys were born. This is all kind of mixed. I don't know how it's ordered, but it uses this athlete ID. You know, you can always use like other keywords like describe to figure out what's in there. This is not super helpful, but maybe something like info would be more helpful on what type of columns we have here. Results.info, see what's in there. Results.head. Okay, so results here, this results data frame, and I wanna kind of show both on the screen at the same time. I might hide this. Um, but this, yeah, results data frame has every Olympic athlete's actual results. So the BIOS is telling us about athletes like this person, and as we can see, all of this person's results are found in the actual results CSV. And then just some helper things for the questions that we'll ultimately analyze. This gives us country codes, so the NOC code to the actual country. It can be helpful for a dashboard that we'll build later on in this tutorial. The um, populations, if we look at that, has all sorts of, yeah, population information for each of the countries uh, that are included in this. These country codes are a bit different than the NOC codes, so that's worth knowing. Um, if the country you're interested in investigating is different, you can just kinda go in and manually replace things and change things around if you need to with these CSV files. Um, I see Ashok asked a question on what, visualization tool we're going to use. We're gonna use, probably a couple different ones. We'll probably use a little bit of Matplotlib. We'll use Folium to do some heat map stuff, but we'll package it all together with a Shiny for Python dashboard so we can kinda tweak parameters like country, winter, summer Olympics, etcetera, and kinda easily see changes in results. Um, cool. So I think to kinda actually kick off the analysis portion, let's, answer a question. So the question is, how many medals has each country won since 1896? And I will share the data file again. Maybe I should just keep this overlay up. The data files are all in this repo. So I'm gonna just leave this up for a sec for people that are kinda just joining in. But this question seems so easy. It seems so easy to just answer, how many medals has each country won? But I think one thing you'll often see in real world data tasks is that oftentimes a simple question like how many medals has each country won can be a lot more complicated than they initially seem. So like a question like this, some questions we need to ask ourselves is like, are we talking about bronze, silver, gold? Are we just talking about gold? Are we talking about winter and summer, etc.? And then I think the other big challenge with a question like this is if we look at our results data frame, so I'll look at like 20 rows here. We have, these are all individual results. We have the National Olympic Committee, I think that's what NOC stands for, I probably should know this. We have this, but we have individual results. So it's just like, do we have to do anything specific to, aggregate all the medals for France in this example because we have these individual results? It's, kind of tricky. Going back to the chat real quick. Yeah, all the links are in the video description. I am gonna remove this overlay. But yeah, it's seemingly tricky. Like, I feel like my initial stab, let's say it's always good to kind of, like, start simple and then work your way up to the correct answer is, okay, like, let's start simple and see if that works. The simplest solution I can think of is, first off, we need to figure out when someone actually wins a medal. If we look at our results, um, maybe we look at the middle column. I might just see what the unique values are there because we see a bunch of NANs. I don't actually see any. Oh, I see a bronze there. I just wanna kinda see what my values are, and we see, yeah, NAN, bronze, silver, gold. So if we wanna just get medal winning results, we can do how about medals equals results, results, and then grab the middle column, and then there's a nice little, built-in on pandas, not NA. I think if we run that and then look at metals, we will see what am I doing? Gotta do dot head. We will just see, metal winners here. Alright, question for chat. Um, question for chat. I see someone saying we can use a group by function. Um, how from this, like, does anyone have immediate guess on counting metals by country? Like, give me a one-liner and I'll type it in, and we'll see if that gives us the right results. I see group by function, so let's do that. What would the group by function be specifically, Ashok, if you can, give it a stab? If your syntax isn't perfectly right, totally fine. Anyone have a group by function that we might be able to use here? May or may not be a trick question here, just by looking at this data and being a little bit familiar with the data. And of course, I have, like, I think, like, a 30-second lag between when I talk and when, you all hear me, so I'm just kinda chilling for a second here. Okay, I'm not seeing the group by function in chat yet. Yeah, we're gonna use NOC. I see my brother chiming in. What a legend. What a legend. Yeah, but, we'll do a group by NOC here. We'll do, group by, um, NOC, and then we can do something like, how about metal and then do a value count? So I think that this will work. Yeah, group by and sum. Value counts will also work, but I kinda want value counts because then we can see bronze, silver, and gold. Um, cool. Uh, I think well, we can check to see if this works. It looks good to me immediately. Um, we can check for specifically, let's say, USA. Okay, and we get this value. Uh, this is where you have to be careful with things, I think, especially with, like, data analysis in general, is you might get a number that seems, like, reasonable, but it may not be as reasonable, I guess, as it might initially seem. So what I would recommend in this situation is, like, I'm maybe it's a good thing, I don't know if it's a good thing or a bad thing, but I feel like I'm just always anxious about not getting right answers, and whenever it's possible for me to double check if I'm right, I like to do it. Um, so in this situation, like, Olympic information, like, high level, like, how many gold, silvers, and bronzes has the USA ever gotten, probably can find it pretty easily on the internet. So I'm gonna real do quick do like a Google search and see if this number looks good. Okay, probably find like a Wikipedia page or something. How many gold medal or how many medals has the USA ever won in the Olympics? And as long as we're like close, there, what is this? Oh, this is oh wow, we already have 2 medals. That's crazy. I want ever in history. Okay, we get this number. I think we're probably can trust this. It's 2,669, and what I would say is that as long as we're close to that number, I'm pretty happy. There's gonna be, like, weird discrepancies probably, like, maybe they didn't count a certain 1896 event that no longer exists, but I think with our data that we're looking at right now, uh, we are way off of that ballpark. Uh, it's yeah, we have more golds than that, and it's like we're more than, uh, double that. So this is obviously not looking great. Uh, um, yeah, we can also add some conditions. The the challenge here and I see some good comments here um, in the chat. I think let's just look at our data again, and so, like, we're way off. Why are we way off? It's, like, not immediately clear, but let's look at our results again. This is, you know, for each individual person, we have results. So maybe let's, like, look at a specific sport or something. I wonder, does football give me soccer? I'm an American, so I call it soccer versus football. I think that I can do football. We can do results. Um, actually, real quick, I don't know if people see that have seen this syntax before. I can do, query. This is just a different syntax. It's kind of cool to see if you haven't seen it. Discipline, I think, equals, football. This might not work. Oh, no. Something like that. I don't ever use the query syntax, so I'm just gonna do it the way I'm comfortable. Does that work? Okay, maybe it's not football. I'm gonna do string dot contains soccer, how about? I'm struggling. Let me just find the, unique disciplines real quick. Oh, wow. Yeah, they're just, like, written weird, so that's why we weren't getting any luck. But let's take basketball, for example. How about let's just get results, results, discipline, and if you wanted to, like, make your life easier, you probably do string that contains basketball if you didn't wanna have to pass in this full one, and then I think you have to say doesn't like that there's NA values here, so I'm just gonna say NA equals full. I think that means we filter out any NaN values. Okay, so here's a big thing on why our medal counts are so off. If people, I don't know if anyone has mentioned this yet in the chat, but if we think about a team sport like basketball, uh, maybe we filter even by, like, 2020, so some of the names are more familiar with everyone. So, to do that, I could also do results year equals 2020. Should work. Okay. Um, like, Sue Bird, Diana Taurasi, they're both on the USA team here in the women's basketball, and they both won gold. If we wanna do m total, medal counts, it's not fair for us to count Diana Taurasi's gold medal and Sue Bird's gold medal as 2 gold medals. Like, they were both on the same team, so we need to figure out a way to basically drop out any team events. And this is like, I don't know, legit things I feel like you see in, like, different types of data analysis tests. It's like, sometimes, like, maybe start simple, but use your resources to check to see if your simple solution works, and if it doesn't, try to figure out why it doesn't work, and then reapproach it. So in this situation, we have figured out now why our gold medal counts are way high, but how can we fix this and actually get actual country counts, based on this information? Um, I'm seeing still, like, some good, queries, so thank you, I think Ali and Ashwarya for providing the inputs. I think because of the reasons I just listed, I don't think those queries are exactly right, but I do appreciate the input. So, okay, now that we know this, I'm gonna just comment this line out. So just to kind of recap, we need to avoid double counting team sports and then some by NOC. So what might this look like? I'm gonna just run this again just so we have. Okay, so I'm gonna just add that comment again. We need to avoid double counting sports, team sports, and then some by NOC. Yeah, we can filter out collective sports and count it just once. That's definitely the right solution, Marcelo. I think my biggest challenge is like, for better or for worse, I feel like I'm lazy and I don't want to know what all of the sports are that are, um, like I don't want the list of all the collective sports. Like I want to do the simplest thing I can. And so in my head, basically, I just need to figure out what are the columns that we're dealing with here. So if I look at the middles again, um, we have these columns, and basically what I can do, I would say, is we can drop duplicates based on certain criteria. So if like the year is the exact same, the type is the same. I mean, I guess there's never going to be a summer and winter games at the same time. The discipline's the same, the event's the same, and the medal, I suppose, is the exact same, then we don't count it twice. So, um, I guess we call this like medals filtered, and maybe I should do this below here, medals line. That's gonna be medals dot drop duplicates, and we just wanna have the subset be, um, year, type, discipline. If we have a couple extra properties, it's probably not a big deal as long as we include as many as we need. Discipline, event, and medal, because they could be doing a solo sport like running or something like that, and we could get the, uh, silver medal and gold all from the same NOC, and we do need, I would say we would wanna keep the NOC the same as well. I'm kind of thinking ahead because there potentially could be a situation where 2 countries tie in an event. I don't think it happens often, but I do remember, like, this video of, like, 2 high jumpers. This was at some world championship, maybe it was the Olympics, I don't remember, but these 2 high jumpers, they both couldn't clear the same amount of height. I think they had the option to try it again or just both take gold medals, and it's just, like, a legendary of them clip of them, like, both, like, dapping each other up and, agreeing to take golds both and just being super excited. So, I wanna keep in mind ties, so I'm gonna count this in my drop duplicates as well. Run this, and then I think we can do that same exact, group by and sum now with medals filtered. Oh, yeah, use yeah, I guess you could use, unique on NOC. I think that was it's kind of what we're doing by dropping duplicates. Ithor, I don't know if I pronounced your username correctly or your name correctly, but okay, let's run this now. Okay, this looks much better. I'm much happier with this, um, result. I think if we go back to that web page, 10 1,077 gold, 841 silver, 751 bronze. We're much closer to the right value. There's still something going on, uh, and that Kira's responding. I think that happened in Tokyo. That it yeah, I need to double check. The video is cool. I'll have to, like, share it on my Instagram or something afterwards. Um, legendary tie, but we're still way above the value we should be at, but we're significantly closer, so I'm excited by that at least, and if anyone's jumping in, late, uh, code is down in the description or repos in the description, and we're currently working on answering the question, "How many medals does each country want since 1896?" Alright, so, what am I trying to say here? I just completely hit a wall with my thought. Okay, we could dive into USA's golds and see why we're still off. Um, I think it might be easier, like, this is a kind of another strategy is like, okay, we saw by doing a Google search, we're not at the correct value that at least the Internet's telling us. The Internet, there could be a little bit of discrepancy, but it should be, in the probably less than 10 range versus the hundreds range we're still at. So because USA is, gonna be at the top of the medal count, I think it makes sense to look at a country that's a little bit lower medal count, because then we can maybe pinpoint why we're overcounting a bit. So, what we can do here is right now we're getting just specifically the location of USA. What I might recommend is that in addition to grouping by the NOC, let's also group by the year and see what that looks like. And I think if we did .toString, we could see everything. That's not what if I do print? Okay, so this gives us everything. We can open it up in a new text editor if we want to. So any of these countries, I would say, are probably fair game to look at. Um, it might take a little bit to figure out where the discrepancy is. Um, real quick, look at a country like, let's see if I get the NOC right. We'll check out, I think MEX for Mexico. Maybe not. Incomplete input. Oh, I have a print. Okay. So real quick, I want to print out total number of medals for Mexico and see if we're right or wrong. We'll make a new cell. So let's see. That does not seem right. Oh, we got to do specifically. Okay, so this is Mexico. 39 plus 25 plus 15. Let's now go back to our table. Mexico total Olympic medals ever. 73 medals. Okay, so do we have 73 here? 39 plus 25, 40, 54, 40? 54, 70. So we have 73 medals, they say, and we, for some reason, have 79. So we're still overcounting, but we're overcounting at a much closer rate. So I think that it's, like, worth, um, maybe diving into this. Okay. So, like, literally, there's different ways to approach this, but how I approach, like, inconsistencies with my data is I take a country, let's say, like Mexico here, that has a more reasonable small number of medals of data points, and because it has a smaller number, it's easier for me to kind of pinpoint where issues could arise. So if we now, like, split the screen here, and open up our Visual Studio Code, have that split the other screen. I think we had this was all of Mexico's metals. Kinda can go through this list and see where something doesn't align. So 1900 looks good, 1932, and I know my screen's probably a little small, uh, um, and thank you for people for doing that math. I see a 79 comment here. Thank you for doing the math that I couldn't do in my head quickly. 1900, that's, like, right. So I kinda would go down the list and see if there's, like, a value that is off, or if there's, like, a year that I'm including that isn't included here. So, like, maybe the years would be a good starting point. So 1900, 1932, 36. If anyone sees a difference here in the data, multiple eyes would be good. We're trying to figure out why we're overcounting. We might be going too quick still. Is there ever a year that's, like, not let me know if anyone sees a inconsistency here. Okay. I see something that is alarming to me. I see this year 2010 when there was no 2010 Olympics. So, like, this is enough information for me to, like, work off of now. Like, what's going on with this 2010 data point? Um, let's specifically look at that. So, just looking at the actual Wikipedia source, and then I'm finding inconsistencies why we're overcounting metals a little bit. And there's this 2010 date that we're counting, but it's not included in the official, like, Wikipedia source. So that's yeah, let's dive in. How can we figure that out? I'll probably work off of the metals table again. I feel like my notebooks sometimes get a little bit messy, but we wanna specifically look up I'm gonna try to use this query function again. Let's see if I can do it this time. Uh, the year equals 2010, and I think this is NOC equals max. Let's see what happens there. I think I need to run this with quotes too, maybe. Anyone know how to use these query functions? Oh, actually, I have 2 equal signs versus 1 equal sign. I don't remember what the proper I never use this. I just think that it's cool that you can. I'm gonna just do it normal again. It's worth another shot. You look up query functions if you're curious on what I was doing. It's like a little bit of a shorthand, but I just always end up doing this. 2010. I swear typing is a lot harder when you're on a live stream. I don't know what it is. And NOC equals max. The simplest bugs too when you're live coding that might be the most obvious thing to ever see. Um, okay. Uh, we found something here. The person that won the medal, the bronze medal in 2010 was this Ivan Garcia, shout out Ivan Garcia, and he won it in diving. But we see the event was, Platform Boys, and I see YOG. We go out on a limb, I think that this is the Youth Olympic Games. So in the data that we scraped from Olympedia, we also included the Youth Olympic Games. So I think we probably don't want to include that if we wanna be closer to the official medal counts, or at least we wanna be cognizant that we're including it. So we could filter that out by doing something like event dot string dot ends with, we don't want to end with YOG. So if we just run this in parentheses and then use the little tilde sign, that means not in the context of pandas. We rerun this, we're not gonna see that data anymore, it's been filtered out. Then we do the value counts. Okay, we go back. Our number we were shooting for was 73. Uh, if I where did my internet tab go? Oh, no. Oh, there it is. We were shooting for 73, 73 metals, and now if we do that quick math, I can find now my Visual Studio Code app. We get 36 plus 24, which is 60 plus 13 is 73. So now we're pretty good, pretty content. I see Marcel commenting on me stressing out about doing simple things. I do see someone did provide the correct query function. So thank you, Thor, for providing that. Okay, try that query thing again. I want to see it work. And shout out to this comment because I think that this will actually work. But now I need a. I'll do it with the results. Right, result dot query. So remember, results is just basically a bigger data frame. Looks like this. If we do the query function, that is so kindly been put on the screen, year equals 2010. Oh, we use an actual and NOC equals MEX. Oh, what did I do this time? I gotta look at that. Now we actually get some results. And this wasn't just from the metals one, so that's why we're seeing some extra. But thank you for providing that. We do see though that we do. This is just another way to filter your data, and it's just a little bit more concise because you don't have to repeat using results in a bunch of places and surround parentheses. I'm just, like, still trying to grasp the syntax, though. I'm just like, it's a newer thing for me. I don't know when it was added, but, it does work, I swear. But thank you for providing that one. Just kind of a separate note, because if people have questions throughout, feel free to ask them. It just looked like a good question that I wanna bring up, so thank you, archers, for asking this. Um, so I think this is a really good question, and I find myself using AI a ton too. I think there's a few things you wanna think about. I mean, you should probably be comfortable with a lot of the basic syntax for, like, a library like Pandas. Like, you wouldn't wanna use AI for everything. Like, being able to do some simple filters just out of the top of your head will be very helpful. It will also give you an intuition for good code versus bad code. Um, that being said, I don't think it's an issue to use Copilot and depend on ChatGPT, et cetera, a lot. I think you just really wanna be able to, yeah, have enough understanding of whatever library you're working with to be able to figure out, is this good code? Is this bad code? Is this doing things that are extra versus is it, just giving me what I need and nothing else? What I can do, I think as we get a little bit farther in this, tutorial, we can try using Copilot a bit more, and maybe I can try to call out some things that I think are good that aren't good. But in general, I use it a ton. It just makes my life so much easier, even if it's things that I could come up with just off the top of my head. But I think the biggest thing is just making sure you can understand what it's producing for you. If you can't understand what it's producing for you, I would say try to look more into the library, look more into the documentation. But if you ever understand everything it produces for you, you just didn't know the syntax, totally fine to just go ahead and use it. I think as long as you can understand the logic, that's what's most important. And so if you're using AI so much that you don't understand the logic, that's where you need to draw the line. So that would be my more concise answer. Yeah, and I see my brother, shout out Bobby, here on the live stream. Uh, I think basically, said kind of, what I was trying to get at is that you need to be able to determine if it's good code or bad code, if what it's suggesting you is correct or not. And then this is another, I think, worthwhile comment. I don't know the specifics about Copilot, but, like, with ChatGPT, yeah, if you're using sensitive data or something like that, and you need to pass it through, be careful 'cause it might somehow be fed into the model, but you can do certain things with, like, ChatGPT where you and this you gotta take them at their word, I guess, for this, but you can have, like, a private session where none of the data is collected that you use during that thread. I don't think it saves the thread for you, but, yeah, if you're doing anything sensitive, just make sure that you're not passing data. Uh, Also, another good comment, the suggestions would be better on popular libraries. Um, we're gonna build a dashboard with Shiny for Python, and I think because Shiny for Python's newer, sometimes I don't get the best suggestions from, like, Copilot for Shiny for Python, so it's really important for, us to look at the documentation and stuff for, newer libraries or just libraries that don't have the database of information. Um, alright, what was we wanna see the, number of medals for the USA. Let's do that. This is kind of like I think everything should work here. Medals filtered. Okay. So this is now our new number for medals for the USA. Did we this takes out the Youth Olympic Games. Oh my gosh. Where's the, uh, medals won by USA all-time Olympics? 2975. Uh, where was that the tab that I just had open? And this doesn't give me the breakdown, but I guess we can do the, Visual Studio Code math here. I can't do this math quickly enough while on live stream, so we're doing it the old-fashioned way. Calculate 2997, and what do we have? Oh my gosh. Where did the internet go again? Oh, okay. 2975. So there's still some sort of discrepancy, uh, but this is a big number at this point, and it's really, like, you gotta ask yourself at some point, um, where do we draw the line? And at this point, 2997, like, at the and then gosh, I'm so bad at this. I'm sorry, everyone. 2975. So if we, do a little math here, 2975 divided by 2997, like, we're so close to being, like, right? Like, we're within 1% approximately, and if you're not, like, publishing this as, like, some big thing or something like that, like, you gotta just ask yourself, yeah, where is the numbers okay to be a little bit off? We could keep diving into it and try to get it more and more precise, but there might be a little bit of discrepancy of, like, events counted in the official total versus what's on Olympedia, et cetera. Like, I'm personally fine kind of to move on with what we have, but, yeah, the process is you really just gotta ask yourself, "Do I need to be even more precise? Why are these numbers different?" And sometimes you have to be uh, extremely precise. If you're CrowdStrike, uh, pushing out an update to all of your clients, like, you need absolute precision because as we can tell with the events of the past week, or 2 weeks, yeah, simple little small errors can have massive effects, but for an analysis like this, I'm fine being just that close. Um, cool. Right. So, and I mean, we could, filter this by any country. We could look up like Zimbabwe. We could look up, uh, probably Great Britain. Look up what would I guess it's yeah, England is Great Britain. Spain. Do all this stuff. We can also filter by winter, summer, etc. And I think we'll include this code kind of in our next step um, of the process. But I think let's kinda move on from the medals. I think we kind of covered what's most important. We'll see it again as we build out a dashboard. Um, Next big kind of more advanced thing that I wanna talk about is, can we visualize where each athlete was born on a map? Another question where it, like, might seem easy enough when you're looking at it, but it's actually a more complex question probably than it might initially seem. So, just looking at this data, how would we go ahead? We have the born city, we have the born region, we have the born country. How could we visualize these birthplaces on, like, a heat map so we could see where all these Olympic athletes are coming from? Anyone have any thoughts? And while people provide thoughts on that, um, where can we practice such pandas code on Dataset? I mean, a few thoughts here. I think, like, the best practice you're ever gonna get, with pandas is, like, analyzing datasets you're personally interested in. So, like, I think that this Olympics data is pretty fun. I've learned a lot from just seeing some weird stuff in this dataset. Like, I was looking at it yesterday, just kind of prepping for this live stream, and, like, uh, on that same kinda topic of, like, medals and, like, eh, or, like, basketball, like, the USA shouldn't win a gold and a silver medal in basketball because there's 1 USA team. But in, like, 1896 or 1904 or something like that, there was, like, only 3 teams total in soccer/football, whatever you wanna call it, and 2 teams were from I think there was only 3 teams. 2 teams were from the USA, and it's like, what the heck was going on there? And I think one was, like, a college team. It's like, the Olympics were a different beast at some point, so you learn these different things. This Galt FC won in 1904, I remember from my research yesterday. I also saw some dude, I don't know what I was looking up, but some dude like Esther, I don't know his last name, was this Olympic medalist that had like a peg leg. He had a wooden leg, like all sorts of information interesting information you can get by just exploring this data, looking at something, and then like, doing a little bit more research on Google. So getting back to your question, find datasets that you think are fun. I think Kaggle's a great place to go to find cool datasets. Um, I would be amiss, I don't know what the expression is, amiss? I didn't shamelessly plug my own videos. I'll probably add to the description some additional videos that we just kinda do some exploratory data analysis stuff with pandas. I think that's a good place. As far as platforms go, I'll shout out, Alex the Analyst Builder is a fun place to practice pandas, as well as StrataScratch, which I think I do have a link to maybe in the description, is another good place. And then the second half of that question, I'm honestly not super familiar with Power BI. I've used Tableau a bit more. We will see, though, Shiny for Python in this live stream, so I sometimes do the dashboard like, I do the dashboards a lot now with Python, using Shiny for Python. So I probably won't do Power BI at least right now, but maybe in the future when I'm more comfortable with it. I like to do things I'm comfortable with. One, I don't see it that, answer the original question, um, the original question about how we might be able to plot this with a heat map. If anyone has thoughts on that, I might just answer some other questions real quick. Um, but yeah, how could we plot this information as a heat map to see, where the dense regions are? I expect to see a lot of people in like, for at least USA Olympic athletes, I expect a lot of like, Los Angeles, Boston, New York City, etcetera. I wanna visualize that with a heat map. Um, if you are I see a question quickly about running Python, I think this is at least with Jupyter Notebook without using the mouse. Uh, Control Enter. or command enter. I think usually it's control enter will run the cell in place, and if you do shift enter, there is a you run it and go down one. So shift enter and control enter, press them at the same time to run those things quickly. All right. So I'm still seeing no answers on the visualization component. The trick here is we wanna put this on a heat map, but I don't think from having a city name in a city region in a country alone, like, that gives us enough information to actually visualize where each athlete was born on the map. So I think if we think about whenever we're thinking about, like, geography and plotting things on map, typically the approach that we wanna use is converting the information we do have to latitudes and longitudes. So here we will use Copilot as someone asked us to, and we'll see if I like the suggestion or not. But given a city, region, and country in Python, get the latitude and longitude coordinates. Usually, for any common task that you can imagine someone would have done in the past, there's gonna be a library or something that exists to handle it. See what it does. Okay, this looks pretty good to me. So, yeah, we could run a I do like the value counts on born city and born region. That's a good way to see where most people come from, but I feel like to know those outliers and to see it visually, there's something really powerful about that. So, I do like this comment a lot, but I'm trying to I guess, take it to the next step. Okay. New York, United States, New York City, and it gives us latitude and longitude. Um, how did I open this prompt window? In Visual Studio Code, you can do Command I to open up this little prompt window. I think you can do that in Python files and JavaScript files. I think that always opens up the Copilot chat. Maybe it's specific to Jupyter Notebooks, I'm not sure, but Command I is super helpful. I use it all the time. Thanks for the question, brother. Can we give a shout out to Bobby in the chat? Shout out to my brother Bobby. He's just been an absolute legend all live stream so far. I gotta give him some love. But yeah, we got city, region. I could do other places. How about we do like, Madrid? I don't know what the region here would be, like, I don't know if it would be Spain. I I I don't know exactly how it breaks it down within our data frame, but see if this works. Madrid, Spain, Spain, it does work. Okay, now let's actually plug in, like, these latitude and longitude and see if it actually gives us what we expect it to. Um, pulling up another window. I'm typing in this latitude and longitude and seeing if it gives me, Madrid, Spain, and we do see I haven't been to Madrid, so I think this is what the heck? What the no, this is what the heck? Something happened here. This is Madrid, like, Philippines or something. So, there is a little bit of, sometimes playing around with things that you need to do, and, like, it's good double checking to see if these coordinates it's giving you are actually right. I didn't even know there was a Madrid in, uh, the Philippines. Uh, So maybe if we, like, just did city, country, or something like that, like, let's see what this gives us. Running the cell again. Is this different significantly different than what we just had? That's so wild that it's giving us it's defaulting to this place in the Philippines or yeah, it's this is crazy. Okay. So, yeah, you see that this works. I mean, let's see if it works for New York. We need to see potentially like you need to double check these things. So it's good to like run some like I like to run things like manually oftentimes um a first time. Run this like 47.1. Like to run things manually and then like kind of double check and see where the issues may lie. Um, and then go ahead and kind of automate things just so I kind of understand what I'm looking out for. See. Oh, okay. Does this give us New York City? All right. That looks good. So at least we know that it for other situations, it gives us the right thing. I bet you if we did like Madrid and then we made this España instead of Spain, like actually did the proper Spanish spelling, I bet you that this would give us a result that's more um, aligned with what we're expecting. So let's just check this. So, I mean, these are the steps you kind of like take, I feel like in the real world sometimes when you're checking to see if something you're trying to do is working. You manually validate some examples and then you figure out how you can automate it. So as we can see, like as long as we had the, proper Spanish spelling there, we do get Spain. So things to look out for. One recommendation, and I don't know if we'll get into this for the purpose of this video, but one way that I would validate that, like, what I expect is working is I would look at my, born city, born region, born countries for my data, and I might pass in to this, like, get coordinates function, different ways to geocode that same information, and if I pass in, let's say, 3 different ways where maybe I include only the born city and the country, and then I include the born city, the region, and the country, and then I include just the born city and the region, I could validate by getting 3 results back, I could validate if they're all, like, the same, and that might give me more precision. So if those 3 geocodes are right within the same area, I'm pretty confident that it's probably doing it right if I, format this in different ways. But if they're all over the place, if I pass it in 3 different ways and I get 3 wildly different latitude and longitude coordinates, then I might need to double check, I would maybe tag that row as something to double check and just see if I need to fix the geocoded information there. But ultimately, how you could approach this with, pandas, if you wanted to get latitude and longitudes for everything, um, we could iterate through our data frame. So we have now this function, and we have the way to kind of use this function. What we could do in pandas is basically for index row in df dot or what was our in bio iterate rows. Yeah, I do see some, maybe, like, including the actual accent signs and stuff too. So thank you for that comment. I didn't see a comment until now, so you probably were ahead of me there. Um, you could, iterate through each row, and this is not the most Pythonic way to do it, but for, like, getting latitude and longitudes, this would be a thing we would have to do just one time and run it for every row. Um, so what I would ultimately do is do something like, uh, lat long equals, BIOS or, like, get coordinates of the row, born year, born city, born region. You might get issues with this three-letter code, but we could, pass it in, born country, and then I could, let's say print lat long. I'm gonna just run it for one row real quick and then okay. How is it returning it? Latitude, longitude. Okay, it's running into an error. Key of tuple not found in oh, what am I doing? This should be my bad. So like, if I wanted to get latitudes and longitudes for every row in this BIOS data, I could do something kind of like this. Um, so for some reason, it's not getting coordinates for that. I think that the three-letter country code might be throwing it off, so I'll try something different here. Let's see if this works. Okay, so as you can see, like passing it in different ways matters. You could use the file we had, NOC regions. This was in the data set, which is linked in the description. But if you wanted to change these NOC codes, these codes to the actual country name, you could use this data frame to help you out to do that. I'm probably not going to dive into all of this latitude and longitude stuff. I'll do kind of the basics of how to approach it. I actually have another data file here that we can work off of to actually visualize some of this stuff and actually get into the um, dashboard that I've been alluding to. But let's see. Okay. So what you could do is if you're and there's a lot of error checking and stuff you have to do, like if your coordinates ultimately are defined, then then maybe before we even run this loop, we define, BIOS, we do BIOS looks equals BIOS.copy, and then I'm gonna initialize 2 columns, lat and long, column to be nones, and basically if the coordinates are defined, then I could do like a BIOS looks dot loc at that index for the lat column, we set it to lat, BIOS looks dot loc for that index for the longitude column, we do longitude And so basically we could run a loop like this that basically tries to get coordinates for all these positions, um, as long as like this function coordinates that we have defined here, and maybe I bring this up just so we have it all one nice piece. And again, I guess one thing to that I will mention right now is like my typical strategy for doing anything code related is I don't care about it being pretty. Things that I show right now are not going to be the prettiest. And yeah, I do see a comment here. Why not apply? This would be more Pythonic, Kira. So I do like apply and actually applying the function. I think this kind of gets into the question I'm about to answer is like I often start with maybe the silliest, simplest, dumbest way to do something. I want to get something to work. And then once it works, then it's a matter of fixing it up, making it more Pythonic, cleaning things up. Iterating over a data frame with pandas is, like, very much kind of against pandas practices, but I also need to you need to think about how many times we need to run this code if we would need to get the latitudes and longitudes. I would say you only need to ever run it once because you get the latitudes and longitudes, you save that as a new CSV, and then you just use that new CSV. You only run it once. It doesn't matter if your code is really non-Pythonic, non-pandas specific. You if this is a function that you only need to run once, and you can keep that information and store it, then I don't care about efficiency as much. So, like, I'm kinda doing the simple way of just iterating over the rows because it's easier to grasp versus trying to do it all in pandas syntax. I only will really need to run it once. Yeah, and I agree, this is kinda my design principle is, like, make things work and then make it look good. Really depends too on, like, is this something that you need to share with your team has to build off of? I weigh the pros and cons, but yeah, I always keep things, um, simple first. So, I guess getting into that, this is now setting the latitude and longitudes for a specific column. Uh, um, I'm gonna just print out each coordinate that we're looking at. Okay, and I'm not gonna run this for everything, I don't think, but we could do something like if index mod 100 equals 0. So I guess I need to be a little bit careful of this uh, because it will cancel on the first one. So if index is not equal to 0 and index mod 100 equals 0, then we'll just break out of this. And maybe before that, we'll save files looks as like 2CSV, um, updated BIOS. And then I like to like if I need to run something over a long period of time, I often like will pass in what index it's at in my file name .csv, and then whenever I do CSV, I usually set index equals false. Um, but we're gonna run this real quick. We see it's getting a lot of those latitudes and longitudes. We see the names of places. We do see some NAN, so you'd want to handle that appropriately. It should never give you coordinates for NANs. So, like, you would wanna handle some of these edge cases. I like printing things out because it lets me have a feel of, like, what are the weird edge like, situations that I wanna make sure that it's handling properly. Another optimization here is you might do, like, a cache. and basically for specific cities and regions that you've already seen. So, like, maybe we call this, like, the key is equal to city, comma, region. So now we're geocoding the key. And if we find the location, and this again, you'd wanna make it prettier, but you could, uh, um, basically add to your cache the specific key and the latitude, longitude pair, and then instead of doing the actual geocoding stuff, um, we can start by just doing like a if key in cache, you could return the coordinates you've already calculated. So you don't need to do as many lookups. You could do something like this. Um, I don't know if that screwed up my running here. Did this finish? I think this finished. We see we have the updated BIOS 100 CSV. We see the latitudes and longitudes, and obviously because we only did 100 here, it's gonna stop at these indexes aren't gonna have any latitude and longitude. But how I would approach this in the real world of, okay, I need to add latitude and longitude, what I would do is I'd basically, keep updating this to CSV. I'd add, like, checkpointed versions. So maybe instead of doing it every 100 rows, I would look at how long my BIOS table is, and it's there's a lot of athletes that have existed in the Olympic history. So what I might do is like, okay, I don't ever wanna go 10,000 rows without this saving as a checkpoint, and then, I'll have all these files, and if something breaks, let's say I lose internet connection and just everything messes up, or sometimes you'll get rate limited, so it won't let you pull all this information at once, then I always have these checkpointed files to go off of. If you do get rate limited, one thing to, try out is you could do like a time.sleep at random intervals in your for loop to basically throw it off, make it seem, uh, a little less predictable and robotic. But ultimately, this is probably gonna take a while to run, so don't have time to show running all of this here, but hopefully you got some context of how you could get these latitudes and longitudes. One thing I do wanna emphasize one last time is, yeah, if you really need to have accuracy with city and regions and the geocode locations that you get, I do recommend, like, passing in the key in a couple different formats and just validating that you get back the same latitude, longitude, or very, very close latitudes and longitudes each time to make sure that, like, you're getting the right spot. Um, Things to think about. I again, though, start simple. You don't need to worry about all these factors. Start simple, get something that works 90%, 95% of the cases, and then get more advanced. I'm not sure if, and so we see, exponential back off is a good thing to look up and the pattern for avoiding rate limiting. Um, shout out to the new joiner. Thank you for the support. What was I gonna say? Uh, I don't know if Nomad I can't even pronounce the the name of the library that we're using, within GeoPy. No Nominatim. I forget if it has rate limits or not. I feel like I've been rate limited before, but that was when I was, like, really, really pushing the limits. So I could be wrong here, but it's good to know about using, like, sleeps and stuff as a way to, as a way to, get around rate limits if they do exist. Alright, we've And this has already been an hour and a half. I always, am overly optimistic with how much I'll squeeze in. So, um, there's tons of stuff I wanna analyze in this data set, but I do wanna build a dashboard using Shiny to process some of this stuff. So let's spend some time doing that. Um, it's not a comprehensive latitudes and longitudes, and it doesn't have all the error proofing that I would like, but I think for enough of your latitudes and longitudes, you can check out this file called bioslopes.csv, to help us plot out some of this stuff. But, another kind of more advanced, more professional aspect of data analysis that you'll want to be able to do is actually build dashboards. And I think it just makes it easier sometimes to analyze the data when you have easy toggles and whatnot. So let's use Shiny for Python to build a dashboard quick. So I'm gonna create a new folder real quick. Oh, can you explain iter rows? Basically, iter rows just allows us to get the index, so the row that we're on, and the actual row information. So, like, it's a series object, I believe, in Pandas land. Uh, So it just basically allows us to get both the index and the actual row at the same time and iterate over the data frame. Super helpful to have both the index and the actual row. So you see that we're accessing a specific like city, specific region, specific country from the row, but we use the index to specifically update the data frame that we want to add a latitude and longitude to. So it just lets us iterate over both the have both the index and the row in our operation as we do the for loop. Okay. So this is kind of a preview too to a course that I am going to release. I'm gonna say on Thursday morning on Shiny for Python, but it's a great way to build, dashboards with Python. So I'm gonna create a folder called dashboard. I'm gonna create an app.py there. I'm gonna go to, um, shinyforpython.com, and basically you can use, like, the playground probably to get started. You could take anything, like app with a plot, sure. Let's copy this. I think it's loading a little slowly just because I'm live streaming, so everything's just slow right now for me. Maybe I have to run it. Um, but if I run this into my app.py, click this little button, I have to save my file first, it's usually helpful. Um, we can start building little dashboards using Shiny for Python. This is just a simple matplotlib chart. Obviously not what we want, but let's make a little country data set analysis dashboard that showcase like metal counts by country. We can showcase the geolocations of athletes. So those are the going to be the two big things we'll show. Maybe I'll do another live stream where we actually build more onto it. Really happy to do that. But this is Shiny for Python. Some things you'll need to do is you have to go to that Shiny for Python website. So good starting point is just shiny.posit.co.py. You can install, get everything worked here. You should, if you did the pip install requirements.txt, you should have at least the library installed. But you see with Visual Studio Code, um, and sorry, my screen's a little messy. I always like it's hard to try to make everything big enough to show off, but also like organized. Um, but I have this little button here that lets me like load my app automatically. There's a toggle bar you can use. Within Visual Studio Code, if you use Visual Studio Code, you can go to extensions and type in Shiny, and that will give you access to, like, run these apps within your browser. To make my screen a little bit cleaner, I'm gonna close this sidebar, close this tab right now. Uh, okay, make this a little bit smaller. Okay. Do a UI.page. Don't worry if you don't understand all the details here of what we're doing. I'm kind of just previewing it as something that's very useful to use, and then I'm gonna be publishing a course, yeah, on Thursday. But I'm gonna just do fillable equals true real quick. What just happened? And I might do I'll get into the details of what I'm working on in a sec. I think this might fill it a little bit better. Okay. This just fills the screen. Okay. So what I'm thinking right now is let's build a dashboard that allows us to analyze our country information. So like show the medals by country, um, show where athletes are from a specific country, et cetera, um, with our data. So I think the first thing I'm going to do is like, let's make like we need to do a few things. Um, I'm going to add input or input select button, and we'll call it country. Select a country, and I'll make it a list of like USA, India, Great Britain. How about star? We'll use all countries with our app though. Okay. We have this little this is a funny comment. Listen, I have to tell you something very important. I love you. Love you too, Crocodile. Thank you for the love. You're my favorite amphibian? You're so much cooler than the alligators. And library again, this is Shiny for Python, specifically Shiny Express, as you can see at the top of the file. Let me see if I can. If you look up Shiny in Python, so I'll type this in, Shiny Python. If you just Google this, you'll be able to find what you need. All right. So we see that we have different countries in this toggle. I'm also going to, how about have like input, how about checkbox, like include winter games or something like that. I'll call this just winter. I'll say it's true to start. So I'm just showcasing some things that we can have here, and I kind of want this to be open by default. Okay, like see now we have a toggle, we have country toggle, etc. You could also do something like the first thing that we are labeling is just an ID. Only include medalists. Okay. Oh, open needs to be open. It's not a true or false parameter. Okay, so you know we can start adding little things to our dashboard. Now let's actually include information. So how about we render a data frame? I see a question. Do you stream regularly? I haven't been streaming regularly, but I'm going to try to start streaming more consistently, maybe at least once a month. But maybe like, as much as once a week would be really cool, but more like once every 2 weeks or once a month is more realistic right now. And I will not remove the stream, don't worry. It'll be here, and I'll try to add some, timestamps. Um, we're gonna learn NumPy, and I always say NumPy and matplotlib libraries. Again, shameless plug, I have some tutorials on those. I think you wanna find projects that utilize, like, NumPy in, like, a real world scenario. I think one example that I liked personally, one of my oldest videos was a Connect 4 game where we used NumPy as kind of our underlying engine to handle the board state. So, you check out the Connect 4 tutorials that I did on actually programming Connect 4. You can also learn strategy too on my first ever video, but that would be a good starting point. I'm gonna try to do also a NumPy solving 100 NumPy puzzles video or live stream soon too, so something to be on the lookout on. I also like this comment. Yeah, Crocodile, if you're still there, I need a Crocs sponsorship. Uh, and this is, Pandas, and what's your question on cohort? I don't plan to have, like, my own boot camp or anything right now. We'll see. See if anything changes like that. Alright, getting back to the app, though. We have the very early stages of an app. Um, I'm also going to import from Shiny, import this reactive keyword. I'll kinda describe what I'm doing as I do it, but let's load in our results data frame. So I'm gonna call this results df. That's going to be, um, PD, and, for pandas too. Df equals pd.read CSV. We're in this data dashboard folder, so we're gonna have to go, I think, 2 levels down to get the right folder. Another way you could do this, if you wanna be a little bit more precise, no matter where you run this from, you could use, from path file or pathlib, import path. Most of the stuff I'm showing with this Shiny, you can find in, like, the playground. So, like, right now, I'm reading a local CSV file, so I'm kind of just taking their strategy here, and I've just kind of done this enough at this point that I've kind of memorized, what I can do, but I don't always memorize logic like this. I'm usually looking at docs or see if I can get Copilot to help me out, but I'm gonna the directory I wanna load is equal to path file parent. That gives me to think the right directory. Oh, no, I need to do parent is in the dashboard folder, parent to get this root directory. Don't worry if you don't understand this path exactly. Okay, does this give us our data frame? Okay, I'm trying to get the, data frame. Okay, cool, we have a data frame here. See that? Um, Now what we can start doing with our dashboard, ultimately, we wanna visualize the locations. So if we look at what's here, the latitudes and longitudes, and we also wanna maybe do the, metal counts by the country. So kinda combine everything that we've been looking at in this tutorial into this final dashboard and then deploy that, and I'll share a link in the description once it's up of, like, the dashboard that you can access this stuff. I might make some additional tweaks kind of offline to make it even more cool, but we can actually include, like, only include the winter games or, include medalists, etcetera, within how we calculate our data frame. So, I think we're gonna get uh, put this actually below this stuff. Does this still work? Okay. Alright, so I wanna ultimately include these checkboxes as actually filtering our data. So to do that, I guess this is not results DF exactly. This is, um, actually grabbing the BIOS informations right now. If I wanted this to we'll do a little bit of things. I need to have a second data frame. This is BIOS DF, and this is results DF. Change this to results. Bear with me, this will all make sense. Technically, I could probably define this directory once, but I don't care if it's defined twice. Um, okay. We have 2 data frames, and we wanna be rendering the results. This looks like the results data frame. I'll pop it out real quick just so you can see it. So this looks good, and it's including this doesn't do anything, this doesn't do anything right now, but let's make it actually do something. So let's filter this results data frame based on those parameters. So if I wanted it to only be a specific country, I could do, um, df df, basically we need to combine like, use this NOC. So df NOC equals input dot country. Okay, then I could filter by only include or include winter games. I could do something like if not input dot winter. This syntax will all kind of start making sense. I'm releasing a course on Shiny, but if not input winter, then we wanna filter out the winter games. So we would wanna do like I might just keep this as df. df equals that. If not input winter, then we wanna do df type, look at this data frame, equals summer. That would filter out and only grab the summer games. We only wanna include medalists, so if not or if input dot medalists, then we would wanna only have df. If we look at the data frame again, medal dot not NA. So using all of this and this reactive calc basically caches the value so we can use it in multiple places very easily. But with this logic right here, and now if I need it, now our data frame is actually gonna update based on these checkboxes. So if we look at our data, look at this. I think this should have reran, but if I change it to India, let's rerun. Are we using this properly? Results DF, input country. I think that should all be good. I'm gonna just rerun it from scratch just to make sure. Okay, open this up. Okay, right now it's showing USA. No, why is he not changing? Oh, there it goes, just taking a second. Now we see we have only India Olympic athletes. If we click only include medalists, let's see if this works. Cool, now we're filtering our table. So shout out to India for the 1932 hockey field hockey, not ice hockey. I guess it's British India, gold medal. Maybe is there a different code for it? No, that looks really Great Britain, only golds. You could also, like, filter out summer games, similar thing, but, we'll do that in a sec. Now let's do the 2 main things that we wanted to do, which was add a heat map of the athletes' locations, and, in addition, let's do a, medals over time. So maybe make 2 functions based on that, display that stuff. So gonna do with UI.card, print medals by country over time here. I like to fill out what's gonna happen in these cards before I fill in the logic. This will be a heat map of athletes, and we can always keep the data frame in this as well. Maybe we put it in its own UI card. And now if we pop open our little dashboard, we have something that looks like this. Uh, filter by India, filter by Great Britain. One cool thing that you can do too is we could actually pass in like the exact lists from our NOC regions document. So I could do something like NOCs equals pd dot read CSV. I'm gonna also just define my directory out here. Uh, clean data, NOC regions. Anyone new joining the live stream, all the data set here that I'm reading these files from can be found in the description. Then I could actually take the from the NOC regions column or from this CSV, we have the region or the NOC column. And what I could actually do is take NOCs dot NOC dot unique dot to list. I could actually get all of those NOC values from that table. So now we see all the countries we might want to have. You could even do like a mapping. So you can pass this in as a dictionary where it maps these codes to the actual more readable version of them. But I'll probably do that in a sec. See if there's any questions right now. No questions right now. Um, don't worry if you don't understand all this dashboard stuff. I'm releasing a course on this, Shiny for Python soon. but I do wanna show because I think it's very powerful with, how we approach this. Now if we look at our data frame, I think this is Afghanistan, yeah, we just get those rows. You could only include medalists, so not as many medalists from Afghanistan, got a couple. Okay, so medals, let's go back to our code from way back when. I'm gonna create a function here, def get medals. Okay, so now our results will already handle. So we're gonna start with a data frame, or results data frame, how about? That's gonna be equal to this results df. We do wanna factor this, probably this Youth Olympic Games stuff in. Uh, Probably would make sense. I don't know. We'll see if I leave it or not. You can add it in, just keep in mind. We have our results. We're gonna wanna drop the duplicates, so we'll call this, I guess we do need to keep, medals if we wanna, in case the results, haven't already filtered it out, we do wanna do this. Um, Drop duplicates, cool, and then what was the last code that we used to actually get the medals by year? Looked like this. Oh, man, there's so many tabs open. Oh, okay. Medals filtered. Our location now is gonna be input dot country. We're gonna print out medals filtered real quick. And bear with me. I mean, this is the life of coding, I guess. Like, not all of it is super fun and exciting. Like, it's sometimes just boring and kinda going through the motions here. Um, but I mean, if you wanna see how kinda real world stuff operates, it is a matter of sometimes not seeing results immediately on the screen, but, we need to now call this get medals. So I'm gonna call get medals here. Not defined. Probably have, might make this a reactive calc too. I think that will work. I might just put this in here. Hmm. Bear with me. Okay, at least I can see the medals here. So this is for Afghanistan. That does look good. If I now change up the plot, change it to like USA, for example. Yeah, we do see the metals all getting there. So now it's just a matter of plotting this. So simplifying and plotting. How can we simplify and plot? I see someone just new. Yeah, we're doing, we've done a few different things. The recording will be here. Right now, we're just kind of, the first thing that we did was, like, using, some data, doing medals by country, and it wasn't, like, the most immediate thing to get to because we only have individual athlete results. And then the second thing we were talking about was actually plotting a heat map of where the athletes are from based on, um, latitude and longitude coordinates. So right now we're putting those 2 things into a dashboard using Shiny for Python, and the data can be found in the description. But yeah, we're using Shiny for Python to make a little dashboard view for this. It's a little bit, this is a little bit more, I feel like, focused, so I'm not, able to chat as much through this portion, but, I think the final product will be worth it. So always know that the code here will be available. So if you're, um, worried about missing something, this recording will stay up. So we get the metals, we go to our analysis. I was just trying to remember, how we, got a more simplified view of our metals. I have the screen is kinda small at this point. This would okay. I don't know if I ever grabbed this. Oh, we never set this to a new thing, so metals by year or something like that. Okay, this will make it simpler. Okay, run this again. Okay, it looks like we might have to deal with errors if there's, nulls. All of this is the type of stuff, like, hard to do right on the spot, but these are the things that kind of you get 90% of the way there, um, and then you fix the bugs, the edge cases. But we do see we got a nice little metals by year. Um, if you wanted to, you could also do a reset index and just basically be able to more easily access the year and the different types of metals. I'll look at China real quick. CHN. Um, okay. Looks a little bit different by resetting the index. It's not grouped together. And you could just do, instead of, metal value counts, I'm trying to think. We didn't care about what type of metal it was. We could have just maybe summed this. And I think now we'll just get the total number of metals, which might be simpler to plot. It's so hard to keep everything on the screen. I wanna make it visible as much as possible. Okay, cool. Oh, no. The sum did not work. How about if I just do count? I guess you can't really sum strings, but you count will work. Okay, that looks better. Okay, this looks more like what we want. Got a year, we got a medal, so now it's just a matter of actually plotting that out with a line graph or something. So I might use handy dandy inline Copilot to help me out here. So this gives us the data frame that we want. We probably want to return metals by year dot reset index. reactive calc. This will all be explained in the course that will be published on Thursday, but just hashes things. But we get our data frame, this new data frame, we'll just call it DF. And then if we want to plot this, I'm gonna just Copilot. So make a line chart using matplotlib um, on my data frame that has a year column and a metal count column. Like I could memorize the matplotlib syntax, but I feel like sometimes I'll just do this, and if it's wrong, I'll figure out the easiest way to plot this. But yeah, I mean, very simple matplotlib stuff. I think if we rerun this now, instead of plot.show, I can just I think return plot. I might not even have to do that. Okay, I'm getting some sort of error. Ah, so I'm getting an error. I'm just gonna look at how they do plots or render plot. That looks good. Just trying to understand how it's done with their examples, and that makes it easier for me. All right. We do have a plot on the screen now. That's good to see. Let's look at USA. Um, oh, this is China. This looks pretty good. I'm pretty happy with this. I think looking at our print statement, if that still exists, um, did we still are printing out? I'm gonna remove the print statement, but that looks like a realistic plot over time. The issue is it doesn't have the zeros in it. So, like, this is only showing, like, for Afghanistan, if we only include medalists, there's, like, 2 bronze medals, 2008, 2012, um, and it doesn't go to 0 for this time, so a fix I would recommend is bringing it to 0 and tick marks only by 1 year. Uh, I don't know if I'll have time to run all the changes because I do wanna get that heat map up because I think the heat map is pretty cool. USA, that looks pretty good to me. We see around here, there's a really high medal count year. Um, so, I mean, I would always, like, double check these numbers, but this looks, uh, reasonable. Cool. So now let's just do the heat map real quick. You can play around and fix this, um, medal counter a bit more. With this, I guess, yeah, if we undo this, I think this will change things. If we look at USA, here it is for or only summer games, if we include the winter games. That does change a bit, and it looks like maybe, we're seeing this weird, up and down motion. My guess here is because we're including both summer and winter, I'm guessing the US is just not winning nearly as many winter Olympic medals. There's also probably not as many Olympic medals to give out, so I think that's why we're seeing that crazy spike, but if we untoggle this, you see a much more consistent, level, so also something to keep in mind here. Cool. I real quick do wanna show how we can, map this to, um, make a dictionary out of this, so given a data frame called, and this is I'm showing again how I use Copilot. Do Command I to pop to open this window. Given a data frame called NOCs that has a column NOC, and if we look at it real quick, it also has a column called region. Given a data frame called NOCs that has a column region and a column NOC, create a dictionary mapping each region to its respective NOC. Okay, we'll see if this works. But I like this because we can pass in this region to NOC into our select box, run this. I think we have to do it the other way. So now it shows Afghanistan. If we look at the table, pop this open and look at like, United States now, wherever it is. You could probably order this too if you wanted to make your life easier because it is all over the place. Oh, I can't even find United States now. I guess the order did help, but let's just look up a random, like, China here. It is cool that we can still get the right CHN value, but showcase something different that's maybe a little bit easier to see which country is actually which country. Belarus. Police. Oh, looks like we have a key error. So there's some things to fix here. If there's a key error, I would recommend actually just going into the data and figuring out how to fix it, or sometimes there's none. That's so if you include the Winter Games for Australia, obviously Australia is not crushing it on the Winter Games. Um, we see how it changed. So it's just cool to see this. We can change our data frame by only including medalists down here. Already getting something different. Heat map, heat map, heat map. I'm rambling all over the place right now. I'm going wild. This is funny. Let's look at USA. Looks at China. I don't know. I don't know. Let's just see some combinations. Okay, cool. I don't know. I'm getting excited by this dashboard. The heat map is really what I'm most excited about. So let's um, figure out this heat map. Okay. So how do we do the heat map? Heat map of athletes. We're gonna wanna use Folium. I think this is gonna be weird. I'm gonna try to import everything here. Uh, Again, like, I know I like the Folium library for heat maps. Using Folium, create a heat map with the BIOS DF or BIOS data frame that has a lat and long column. I feel like this gives me my template code, and I can change it as needed. So, import Folium. Cool, oh, it does the import there too. Honestly, this looks pretty good. This is giving me a latitude, longitude starting point. How do I get the BIOS data frame? Okay, BIOS DF, that's right. Honestly, this might already be good. Instead of render plot though, I need to do, render UI. That is one thing I remembered. Oh, no. Why did you put it here, code? Oh, no. It overwrote my, it overwrote some of my existing code, so I'm gonna just copy copy that real quick and then put it where it's supposed to be, down here. So I think I need to render UI here, and I need to import full name again. I'll be so stoked if this already okay, Folium has no attribute plugins. I don't know what the deal is with that because it definitely does, but I did notice the other day I had to do from folium.plugins import heat map, and then I can just directly call heat map here. I don't know why it doesn't think it has plugins when watch the video. This will work. Okay, it cannot contain NANs. So because we're only using the BIOS data right now for this heat map, I'm fine modifying how we grab the data, and I'm gonna do df equals df, but we're gonna filter. We're gonna make sure that df lat is not NA, and we're gonna make sure also that df long is not NA. That should fix the error we were so pumped if this works. Oh, look at that. I don't like how it's filling it right now. I'm gonna, make this fillable true, not actually the case. It should just expand to a more natural size. Doesn't try to fit everything in the screen if it doesn't have to. Okay, awesome. So look at USA. We have this super big heat map, and what I will say is if we actually zoom in, like, let's confirm that this seems to make sense. Like, I expect a lot of Olympic athletes to come from the Boston area right here, and we do see that nice heat spot here. I'm from New Hampshire, though, so I'm curious if there's any New Hampshire we do see some New Hampshire people. I could, like, validate that these are actually athletes. Um, what other big cities? I expect LA to be a big hotspot, so, like, using this do we see LA? Yeah, LA is a big hotspot here. San Francisco is a big hotspot. Going international, I expect a lot of people in Madrid, maybe, as far as Spain goes. Uh, shoot, this is where I'm showing my ignorance. Where was Madrid again in Spain? I haven't visited, but yeah, kinda validate that the heat spots are where you expect them. But if we wanted to just show the country, not the full world heat map here, I that's funny. I like this comment. If we wanted to just show the country, we could just do a filter on the where am I? We could do a filter on BIOS data too. So basically, just like we did it here, we pass this filter into the BIOS data. I don't know if it matters really the order. It probably would make sense to filter this out for I don't know. I don't know if it really matters. Okay, now we're only gonna see the heat map for the specific country we care about. I also think it should do a good job of probably centering in I think this is called NOC, big caps in this data frame. Okay, pop this open. I don't know if we had location information, maybe we didn't get it for those Afghanistan, individuals, Olympians. So, this is their results, so I don't know if we have information on Rohala, or maybe because I mentioned we didn't get the Latin launch of every single individual, we might have some issues here. If I go to, like, United States, NAN, if I go to NAN, that's not gonna work. Uh, wow, I cannot find US in this new updated, uh, I need to sort we're gonna sort these alphabetical. How do I do that? Can I sort a dictionary? What happens here? Does this give me my alphabetical order I'm seeking? I think this sorted it. USA. Oh, why? It's still USA here? It's not United States. Um, location values cannot contain NANs. They shouldn't contain NANs. Didn't we filter that out? Oh, wait. We filtered it out here, right? I feel like it's erroring out and then it won't let me refresh it. Are you using the right data frame? I'm gonna make the default value USA real quick. I believe I can do that by doing here and do default. I think it's breaking on Afghanistan and then it won't re-render it. How do I make a okay, selected. Let's rerun this. Come on. Come on, heat map. Still telling me location values cannot contain NANs. Like there's some weird stuff going on here. Like, I see, like, multiple options of all of these. This is not a terrible idea, honestly. I definitely could integrate with LLMs and LangChain. Why am I having so much trouble with this, filtering out the NANs portion of this? I wanna just remove the sort real quick. I don't know if this did something weird. I also feel like I have some name collisions that could cause weird stuff. We're so close. I have, like, 3,000 tabs open right now. Getting a little overwhelmed. Alright. I don't like that I'm naming this DF and naming this DF. What if I'm more careful and call this bio? Oh, did I also call it DF? Okay, no. These are the things that they never happen when you're coding by I don't know, I guess they always happen. It's just you're not no one's watching you. You try to fix it. What happens here? Is it gonna give me that error? Location values cannot contain NaN. How is it containing NaN? Okay, it's definitely causing issues on this line. If I remove this line, I guess that can isolate our issue. I think NOC is used as NOC, is it? Let's see. We're loading in I we're loading in the BIOS data. We have NOC, it's capitalized in this one. It was lowercase in the other one, so that is like a definitely a cleaning thing I would recommend adjusting. Pop this open, my 50,000 tab. Again, it works, it's just a filter step, so I just commented out the filter step. It does all this heat map stuff looks good, it's just really a matter of can we get it to update properly. Okay, we're running into an error here. I'm gonna real quick I think my recommendation here, I'm gonna print input.country. I'm guessing maybe we're getting not what we think. I guess in this case we are. No, that's right. This is so weird. I'm gonna just try France real quick, see if maybe something about USA is breaking it. Wait, BIOS logs. Oh, the NOC on this table is oh my god, I gotta use born country, not NOC here. Okay. The born country might break some stuff, but I'm glad we figured this out. And sometimes people compete for a different, NOC than where they were born, so that's another thing to keep in mind. Moment of truth. Pop this open. 50 thou oh, look at this. We do see we have some outlier data points that maybe got messed up. Or maybe people that, this is a probably maybe a French Canadian, I don't know. There's things that we would wanna check out. Is this a French island? But if we look at France, you see the heat maps there. It's only showing France. I now update this to USA. Cool. It will center it on USA too, which is cool. See that. See the medals. That looks cool. Any Alaska? Yeah, some Alaska people, not ton. I might also just there's some people that I haven't aren't included in the zips. You see some people from Hawaii. Alright, what country should I look at? Someone tell me in the chat. Alright, check out, like, India, how about I need to restart this back in alphabetical order. I'm dying over here. Alright, got India. Yeah. I can't confirm if these are the places I would expect more Olympic athletes to come from or not. But, I mean, for the US and other countries, it seems pretty good. Okay, I'm happy with this dashboard. Madrid, Philippines. Yeah, I don't even know what's gonna happen if I look at the Philippines. Maybe we got some Madrid, Philippines people still there. Someone asking about the data. I explained it at the start of the live stream, but the data is coming from Olympedia.org, and then we use Nonomatin. It's all covered in this tutorial. The recording will exist after. Where's Phil? I don't know where Madrid, Philippines is. It's so funny that things like that happen. You gotta be careful. Um, I saw Brazil. Let's do Brazil. I need to sort this back in alphabetical order. I think that maybe it is mostly in order. We got Brazil here. Yeah, I'd expect I don't know the Brazil landscape a ton. I think, anything you'll see probably more coastal, more people on the coast. Sao Paulo. Yeah, big heat spot at Sao Paulo, that makes sense. Big heat spot at Rio de Janeiro as well. Cool. Um, I think that's probably where we're gonna leave this. What I am gonna do real quick, though, is we're gonna deploy this 'cause it's so hard to follow a live stream code. I'm gonna deploy this. So I'm gonna just quick copy this requirements.txt. I'm actually gonna put it in the dashboard folder too. Um, no, that didn't work. And I'm gonna deploy this to using Shiny. Um, this is all covered in the tutorial that I'm releasing on Thursday, but I'm gonna deploy this, just call it like Olympics, I suppose. I realize I need to be in my dashboard folder. Mm, Control paste didn't work there in my terminal. Okay, we're deploying this app. And why did it do a little tilde at the end? Called Olympics. This is gonna be accessible. This is all through Shiny. It's gonna be accessible. You'll be able to access Olympics or like keithgalli.olympics.shinyapps.io, and should it'll take a second. Any questions while this uploads? And obviously, this wasn't a perfect app. I think there's those edge cases that I keep kind of referring to. Oh, shoot. I did want it in alphabetical order. I should have done that real quick before I installed. Should have just re updated this line. I'll re deploy it after. Not a perfect app by any means, but it's kind of cool to see what you can start doing with like a dashboard like this. Saw how we could do Latin lawns and like stuff like this. Metals by year was a little bit more complicated than we thought. There's a lot more you could do, and maybe I do another live stream on this, um, kind of diving into some more details and answering more questions about the data. But I did want to kind of cover some more sophisticated things. Mm. So, preview of the Shiny app. I see a question about that. I don't know if this is the most complex, I would say. I'm gonna let it boot up real quick. But this is what we're building in the series that, that or like the video that course that I'll release on Thursday. You also can actually see the initial videos on Posit's channel, right now. I think I linked the first video in the series, in the description. This is a Shiny app too, much more, polished than the one we just built because I had some time to style and do all the, bells and whistles. So this is like some sales data. What makes this particularly cool though, well, it's more complex because I actually used HTML and CSS to, like, do some of the styling, and, I mean, that's one thing that I like about Shiny is that, versus I'm not as familiar with, like, I've used Tableau, I haven't really used Power BI, but I felt like I was restricted oftentimes, or, like, I like this because these apps that you're seeing, like this right here, like, this is Plotly, this is Seaborn, this chart right here, this is the Folium that we just kinda played with, this one here is a what's it called? Altair charts. Like, I can use all the same Python that I'm comfortable with and put all of those in a Python dashboard, which is why I get excited, versus I'm just more restricted, and because I'm a Python person and comfortable in Python, I like being able to deal with this. Um, I mean, I probably made more complex from a data perspective apps, but, I mean, this is pretty cool, and yeah, the course it's just gonna be on YouTube. It's free, or it's just a longer 3-hour video. First couple videos in the series can be seen on Posit's channel, linked in the description right now. I see also why shiny. Um, I would say within Python, so, like, I guess baseline, I'm comfortable with Python. Um, I'm I can use Tableau, I can use Power BI, but I like just staying in the Python ecosystem if I can. So really, I feel like my 2 biggest options within Python are Streamlit and Shiny, and honestly, a lot of times can use them interchangeably, depends on who I'm working with. Someone's more comfortable with Streamlit, I might go with Streamlit. Um, reasons to go Shiny specifically, I mean, the biggest one is the reactivity component, so this is covered in the course, but, like, if I update this toggle with, the specific areas I'm looking at sales data, none of these other charts have to update. If I update this, nothing else updates around here. So I can update specific components on the screen, but not update other things. So, like, it's very optimized for being efficient in rendering different components in different places. Whereas in Streamlit, I'm not as like, I guess I'm not an expert in Streamlit by any means, but oftentimes when you make these tweaks and stuff, the whole app has to refresh. You can't change little components as easily on the screen without everything kinda refreshing, and if you have some data intensive or just processing intensive components, can be challenging. Um, uh So, yeah, that's a little bit of that, but oh, no, the application failed to start. Why did it fail to start? Um, it might have failed to start because I didn't include the data in this folder. I need to include the data. Alright, I'm gonna just copy all these data files. I do wanna have the app ready for you guys to look at. Glad you like the look of it. Um, I don't think the interactive filters are hard to build out. I mean, we looked at them a little bit here, like, with the selecting a country here. I would say, like, logically, the filters can be hard to grasp at first, but once you get the hang of it, so, like, we're building the interactive filters on the screen here. Once you get the hang of it, it's pretty easy to understand. So, like, I define a country filter with this UA.input select, and then I can access that filter by doing input dot so we see input dot country. So this key right here is how I define it and use that property, whatever the input select button is down here. So I just need to do input dot country and then add the around it, import some of these components here. I did because it broke, I did sort the countries. We have it now here. So I just need to add the data files real quick. Let me do that. Because I put the app in this dashboard folder, that's why it's kinda being a little, um, tricky. I should have probably just put it in my root folder, but there's a lot going I didn't wanna, I didn't wanna put it in the root directory just because this repo is more of like a dataset repo, and I didn't wanna, like, confuse where the data was by having a bunch of other random code. Okay, give me a sec. I'm doing it on my other screen. I guess we didn't also, cover the population density stuff, but that is an experiment you could do on your own. Um, dashboard. Okay. I now have these files in here. If I do thing okay, they're now not in parent, they're in parent. I think that this should work. Let's rerun the app and see. Okay, yeah, it looks like it's working again. I think because we added the data files in the right spot, it should now properly work. Let's redeploy. I'm doing Control R2 to get my last typed in terminal command. Shout out to everyone that's still here watching. This has been a marathon live stream. I think it's cool what we built at the end of it, but just shout out for everyone that's stuck through and asked a lot of good questions. Appreciate all of you. While this is installing, I'll share my screen again in a sec, but do how do I do this? Um, bear with me. Real quick, just because we're kind of getting towards the end. So we're seeing how we're deploying it with shinyapps.io. Oh, finally it's loading, but I think it actually worked. Hopefully, we'll see in a sec. We're seeing how we're deploying it with shinyapps.io, but it's really just like one way to deploy Shiny apps, and it's um, I guess yeah, it's one way to deploy Shiny apps, and it's not like the most sophisticated. Like I can get a website out, the app that we ultimately have, but if you need like fine-tuned security controls, if you need to like have it auto update on a routine schedule, if you need to, let's say, like, yeah, share it with only certain people on your team, but not others, or just like work within the confines of a kind of more strict IT ecosystem, Posit Connect, linked right in the top of the description, is gonna be the best way to go as far as Shiny apps go, and in addition to Shiny, Cordo, other Posit offerings, you can also deploy your Streamlit, your Fast API, all of your different Python apps via Posit Connect, so you can check it out, top of the description, and I shout out to Posit and Posit Connect for sponsoring this live stream. Um, basically, I find that oftentimes, yeah, deploying and just all those upkeeps, those, uh, like, just the data infrastructure, the analytics infrastructure, like, I just wanna do my analysis, I just wanna do the data science, and in terms of our Olympics data, it does not need to be an Olympic effort to maintain all of your analytics infrastructure. Posit Connect is a gold medalist when it comes to my cheesy, my cheesy brought to you by Posit Connect. It takes out all the hurdles of your data science journey, leaving you a smooth race to success. You can think of Posit Connect, I would say, as your analytics pole vault, helping you clear some of the highest bars with ease. That's my, I think that's all the puns I have right now, but yeah, check out Pause and Connect, top of the description. Let's see if we have our app working. I think it should. Okay. Hide presentation, hide. Um, I got it. Um, let's see. Share screen, share screen. Oh, let's go. If you go to this web URL, you can try out the app, keithgalli.shinyapps.io/Olympics. Check out Jamaica. They have some good runners. Obviously, it's a very confined heat map. Don't want to include winter games for Jamaica. And again, yeah, you probably would want to add the zeros here, but it still works. Japan. Pretty pumped on that. Um, I should have come up with more puns. Yeah. I think I need to incorporate more puns in general. Just I think it just makes everything better. Okay, I'm trying to think, is there anything else? I'm pretty happy with the stopping point. Obviously, it's not perfect, but I don't know, we have an app that you can actually try out. I'll add the link to the description. Maybe I can add it to overlay real quick, just so people don't even need, where did I have way too many apps open. This is the, you wanna check out the app right here. Hopefully, it works for everyone. Thanks, big bro. Thanks for tuning in. You're a trooper. Alright, I think that's where we're gonna call the live stream. Thank you everyone for tuning in. Um, yeah, this was a lot of fun. I'll definitely try to do more. Leave me some comments down below, um, if you have suggestions on future live streams. Definitely I just need ideas. I think for videos in general, live streams, all of that fun stuff. I wanna do more, but I feel like I spend cycles and cycles and cycles just thinking of ideas to do, and then I don't know, just I don't make anything. So the more ideas, the better. Uh, leave some down below. If there's anything else you'd like to see with this Olympics data set, or if there's specific data sets in the future, let me know. New posit or new shiny for Python course coming on Thursday. You can get started watching it. Linked down in the description. Do them. Cool. I think that is all I got. Thank you again to Posit and Posit Connect for sponsoring this live stream, and I hope everyone enjoys watching the Olympics. I hope you have a great rest of the weekend. Thank you all for tuning in.